Hey guys, Mrs. Millsap here. In this video 4.5, we are going to be talking about valence electrons and Lewis dot diagrams. Get excited. Okay, so let's define the word valence electron, shall we? So valence electrons are electrons in the outermost energy level of an atom. What does that mean? The outermost energy level, when I'm talking about the outermost energy level, I'm only talking about the s and the p orbitals. So that means that when I'm talking about s and p orbitals, what I'm really saying is that this d block, we're going to pretend like doesn't exist, and the f block, we're going to pretend like doesn't exist. So we're only talking about the s and the p blocks. Those are the only ones. When I'm talking about outer energy levels, I'm only talking about groups 1, 2, and 13 through 18. So in the first energy level, remember that the periods stand for the energy levels. These are periods, and they stand for energy levels. How many electrons fit on the first energy level? 1, 2. Remember, we're only looking at the s and the p blocks. So 2 electrons can fit in the first energy level. All the others, if we just look at the s and p blocks, they'll fill 8. So level 2 has 2 electrons there in the s and 6 electrons in the p. So 8 is the outer energy level. 8 electrons fill the outer energy level. Same with group 4. There's 2 electrons in the s and 6 in the p. Again, so its outer energy level is 8. So whenever I talk about valence electrons, I'm talking about how many electrons are in the outermost energy level, and that means we're just looking at the s and p blocks. The maximum number of valence electrons you can have in the outer energy level in the s and p blocks is 8. So if I gave you an element like a boron, boron has 5 protons because its atomic number is 5, okay? If its atomic number is 5 and it has 5 protons, that means if it's neutral, it also has 5 electrons. So here are the 5 electrons. We see the 2 around the first energy level, and then there's 3 on the outer. So how many valence electrons do I have? Well, I just circled. There's 3 valence electrons, or 3 outer electrons, so I know its valence electron number is 3. Now, how could I know that if I just looked at its electron configuration? Well, valence electrons are just on the outer energy level. So I'm not even going to look at any electrons, I'm not going to look at any electrons in the first energy level because the outermost energy level is 2. How many total electrons are in that second energy level? It's the outer one. There's 1 in the p, there's 2 in the s, which is 3. Okay. You can also look at the noble gas configuration or the shorthand, and you can see that there's 3 electrons. All right, let's do another one, like oxygen. Oxygen has 8 protons, so it has 8 electrons total. Well, I don't want to know my total number of electrons. I want to know how many valence ones I have. Well, if I look at the electron configuration, again, I'm not going to look at anything in the first energy level. I'm only going to look at my outer energy level, which here is 2 is my outer energy level, and I have 4 electrons in the p and 2 in the s. So it means my valence electron number is 6. You can also just easily look at the periodic table and find out how many valence electrons an atom has, because the group numbers here stand for the number of valence electrons. Remember, we don't look at we don't look at the D block or the F block. Anything in the first row of the S block have 1 valence electron, okay, because they all end in S1. Anything in the second row of the S block, they have 2 valence electrons because they have 2 electrons in the S block. So group 1 have 1 valence electrons, group 2 have 2 valence electrons. What about group 13? You might be tempted to say they have 1 because they only have 1 in the P, but you forget that the outer energy level also includes the S. So they really have 2 from the S block plus that 1 in the P. So anything in group 13 really have 3 valence electrons, and so on and so forth. So you should begin to see a pattern, and that pattern is that the group number tells you the number of valence electrons inside of an atom, and we are again not looking at the D or the F blocks. The only difference is that group 13 has 3 valence electrons. They don't have 13, they have 3. Group 14 have 4 valence electrons. 15 has 5, 16 has 6, and so on and so forth. So which group has the most number of valence electrons? That would be group 18 because they have 8. Remember, 8 means they have a full outer level. Okay? So we call them the noble gases. Anything that has a full outer level we refer to as the noble gases. All the other elements do not have a full outer level. Which leads me to my next point, and that is that all atoms want to have a full outer level. That's called the octet rule. We're going to come back to the Lewis dot diagrams. So for right now, just skip that and turn your page and go to the octet rule. Octet rule, all atoms want to have a full outer shell of 8 electrons. For example, let's take a look at bromine, okay? Bromine has 1, 2, 3, 4, 5, 6, 7 valence electrons. It's in group, if you look on the periodic table, it's in group 17, which, if you remember from just a moment ago, the group number tells us how many valence electrons there are. So there's 7 valence electrons in bromine. Bromine wants to have 8 valence electrons, but it only has 7. So what it's going to do, if it's given the chance, is it's going to want to steal an electron from another nearby atom to get a full 8. Whenever it steals an electron, something happens in the atom. Bromine's atomic number is 35. What does that mean? Well, 35 is also the number of protons. Remember, protons are positive. So we have 35 positives, right? And in a neutral atom, that means that there are 35 negatives or 35 electrons, right? So what happens then when bromine steals an electron? It no longer has 35 electrons. How many does it have? That's right, it has 36. Oh, now I get it. I do sound like Dora the Explorer. That's just the worst thing ever. So 36 electrons and 35 protons do not equal each other out. So my atom is no longer neutral. If bromine steals an electron to get a full 8, then it's now negative. So it has a charge of -1. Okay? Anything in group 17, they all have 7 valence electrons. They all really want one more. So when they gain that other electron, when they steal it, they're actually stealing another negative charge, so they become -1. So anything, let me take us back up to our periodic table. Anything in group 17, they want to steal an electron. So anything in group 17 will try and have a -1 charge because it's trying to steal an electron. Let's think about group 16. They have 6 valence electrons. They're very close to getting 8. How many do they need to get 8? They need 2. Guess what happens if they steal 2 electrons? If they steal 2 negatives and they hold on to 2 negatives, they become a -2 charge. Okay, so we're going to work all the way down on this. Group 15, how many do they need to get a full 8? They need 3. So they would steal 3 to get really close to having 8. Group 14 is a little bit of a weird group, so we're going to talk about them in a second. Let me go down and talk about group 1. Group 1, like sodium's in group 1, they all have 1 valence electron, right? Group 1 they always have 1. Are they anywhere close to getting 8? No. So instead of stealing 7 electrons, which would be a lot to steal, okay? It's a little bit crazy. It's like a huge heist. Instead of doing that, they decide that they would rather give up their 1 electron. They'd rather give it up so that their outer shell underneath now becomes their new outer shell, and guess what? It's filled. So the rule is if you're close to getting 8, let's steal to get 8. Or if you're closer to 0, let's just give up what we have so that underneath we have a full shell. So anything in group, where am I? Group 1 is going to have a +1 charge. Whoa, where did I get that? Holy crap, calm down, Miss Millsap, you're getting cray-cray. If sodium has an atomic number of 11, that means it has 11 protons, right? 11 positives and 11 negatives, so the charge is neutral or 0. What happens then if it loses an electron? It now has 10 electrons instead of 11. So now 11 minus 10 means 1, right? I now have a +1 charge. You can think of it like this. Giving things away to other people is a good thing. It's positive. So I lost a negative. I got rid of a negative, so I became more positive. So anything in group 1 has a +1 charge. What about group 2? Are they close? They have 2 valence electrons. Are they closer to getting 8? Or are they closer to giving up the 2 they have and get to 0? Well, they're closer to 0, so they're going to give away their 2 electrons, making them have a charge of +2. Group 13 is going to operate the same way. They're closer to 0 than 8, so they're going to give away their 3 electrons, outer electrons, to have a charge of +3. Group 4 are the weirdos. So I love weirdos. So group 4 or group 14 happens to be my favorite group because weirdos are super cool. But group 14, they have 4 valence electrons. They're halfway in the middle. They're just like, Akko taco, what do I do? Do I steal 4 to get 8 or do I lose 4 to get 0? Because if they steal 4 electrons, they'll be -4. But if they give their 4 electrons away, they'll be +4. So depending on the element and depending on the reaction, sometimes they'll gain 4 electrons, sometimes they'll give the 4 electrons away. Last thing I want to teach you guys are Lewis dot diagrams, and then I'll talk about vocabulary. Man, I'm like totally all over the place today. I'm sorry about that. Okay, Lewis dot diagrams is just a way to draw atoms with their valence electrons. So if I have an atom in group 2, that means it has 2 valence electrons. So I'm going to draw 2 dots to represent the 2 valence electrons around this atom. Think of the element as having a box. I'm drawing these 4 lines, but normally you don't draw the lines, okay? I'm just drawing the lines just to show you that this is in a box. So if it has 2 valence electrons, I can draw 2 dots. I can really draw them anywhere as long as I don't draw them paired up together. Okay, the dots don't want to be paired up until they have to. Group 14, they have 4 valence electrons, so I draw 4 dots. Okay, again, none of them are paired up. And those 4 dots stand for the 4 electrons. Group 16 has 6 valence electrons, so I have to draw 6 dots. So that's 4, this is 5, and this is 6. So 2 sides are going to be paired up, and 2 sides are going to be singles. Okay, that's 6 dots. Group 17, I should only have 1 dot that's free, because see, now I have 7 dots. Group 18 is the only group where like all of the dots are paired up. So that's called a Lewis dot diagram. It's really easy. You just figure out how many valence electrons are there, and then draw them around your element symbol like it's a box. Okay, so let's look at some of this new vocabulary. Charge is when an atom has either gained electrons or lost electrons. Negative means that they have more electrons, and positive, sorry, my handwriting is kind of sucky on this, means they have fewer or less electrons, okay? An ion is just an atom with a charge. A cation has a T in it, which stands for a positive ion. Anion has an N at the beginning, which stands for negative. So that's a negative ion. So this electron, this atom has 1 valence electron. It's going to give it up, right? Because it's closer to 0 than it is to 8. When it gives it up, it's going to have a +1 charge because it has fewer electrons. So I would say this is a cation. Whereas nitrogen has 5 outer electrons, so it's going to try and steal 3 more electrons. So it's stealing 3. It's going to have a -3 charge because it's getting more electrons that are negative, and we call it an anion. That is it for this video of valence electrons and Lewis dot diagrams. I hope you had as much fun as I did. and go make yourself some popcorn, kick your feet up, because you are done with Chem tutorials for this unit. I almost called them Chem toots, which I actually kind of like, kind of dig in the name.